All
Sounds
right.
good.
Thank you so much, Michelle, Alex, and all the folks in COLONTOWN and everyone in the audience to be being here and discuss opportunities to exchange about these, things are happening in the AI space. So very excited to have this session today. So for those who want to know more about me or exchange online, I'm Dr. Arturo AI. You can find me there. So let's get it off. So the first thing is, how did this AI came about? Like, where did it come from? So just to give you some context, oncology particularly has had two major technical evolutions or revolutions that happen actually. First is the amount of big data. So now we have the ability to collect information through the medical records because that's how we document our visits together. And that created a lot of data that before, we just like scribbles on the hand. Now we have something that we can extract and make insights. And on top of that, we had developed a lot of tools to diagnose patients better. So we have the advent of, biomarkers, genomic information, and all that has led to a really significant growth in medical knowledge. And to the point that it's almost hard to keep up for even for the most diligent ones. And the amount of information being so random, so heterogeneous, so variable, gives us an opportunity to organize it. And we can learn from history, right? So just one example, the first census in the United States, it took 8 years to collect information for the whole United States. And, the population was much smaller. So they had to develop algorithms at the time with punch cards to be able to collect information faster and have a machine to be able to collect information in we call a symbolic algorithm with logic. So the same can be done now to organize information in medicine. And for those who are still learning about what do I mean by biomarkers. So the first thing is how we diagnose or and classify cancers. So, immunohistochemistry is one of those assays where we do stains with different colors in the tissue that is from a biopsy or from surgery, and we can classify whether or negative expression of a protein, like for example HER2, or if they have MSI high, this you will look for the positivity or not of those mismatch repair enzymes. And then fast forward, we have FISH, which is just immunofluorescence. Basically, we put a fluorescent light and see changes in the DNA. And most recently, we have next generation sequencing, which is looking at the whole DNA and all the changes that happen on those nucleotides, right? So the nucleotides, those bases that are listed in the book. So if the DNA is a book, when we do next generation sequencing, we're reading the whole book with all the instructions and see where the typos are and what page. And before, it used to take a long time to read the whole book. So the whole, Human Genome Project, it took over a decade and $1 billion. And now we can do it basically with $200 in the kitchen and whatever you want. And we know for a fact that every cancer patient, particularly when they have metastatic disease, they should be profiled. So now is ubiquitous, is everywhere, and that lets us to have a ton of information from readout of the whole genome and the interactions between them. And we're looking also at other things happening on how the cells organize information, etc. Um, as a side note, we have this circle here with a human little Vitruvian, like the guy from the Da Vinci, where all these little circles, each circle of them is a cancer type. And all the extensions here and in terms of like colors and stuff, they represent new drugs that had been approved because of clinical trials, because of new drugs that had been tested in patients and show positive results compared to the prior treatments that were available. And as you can see, there's tons of them, and this is just an example of a few years. And every year we have more and more medications, different mechanisms of action, from targeted therapy to chemotherapy combinations, plus immune checkpoint inhibitors, plus bispecifics, plus CAR Ts, and all these different things that are happening and very exciting. But of course, tons of info come with that. And on top of that, the complexity of clinical trials. So we have now knowing that chemo doesn't is just not one term, it's just a term that encompasses tons of different medications. and a treatment is very personalized these days. And it's all because of these kind of designs of studies. So the umbrella trials, the basket trials, those are all studies that, for example, umbrella trial, let's say all patients with colon cancer, and we're classifying them based on the biomarker that they have. In a basket trial is that a study where it doesn't really matter the cancer type, what it matters is the biomarker itself, and we put patients on those different baskets of arms and cohorts, and we follow them. And that's had led to a lot of different treatment options for patients, which Dean's in also on hematology side. So for those in the audience that are also curious and they're just talking about colon cancer, but just as a whole, there's a lot of things happening in that space as well, through cooperative groups and beyond. And adding on top of that is the what we call the dynamic changes that happen with DNA. So as you can imagine, we are humans, we're not static, right? We change on a daily basis. The cancer changes as well. The things around us change. And we are now monitoring changes in the DNA that happen with treatment, before treatment, after treatment, because of treatment. And that has led to a lot of information that's being added up over time. And that means that we need to monitor patients from even before that for diagnosis. We are now using these tools, finding tiny pieces of DNA in the bloodstream to diagnose cancer. And for those who know, in the colon side, we use also in other samples, like in the stool. The screening test that we use for stool sample is looking for epigenetic changes, basically changes on the methylation of genes in the stool. And that's how we can say this patient may need a colonoscopy now because of it. So once again, preamble to why is AI becoming relevant now? So this is not a new topic. It's actually the first time we said AI was 1956. And it started as a summer project by this gentleman here. This called the Dartmouth Summer Research Project on Artificial Intelligence. Of course, it went way beyond a summer, and it went through 2 winters for 2 reasons. First, as many good ideas, it may not be ready for prime time. So we didn't have the amount of data that we needed to make artificial intelligence happen, which is basically an algorithm that is able to perform a function that a human will do. And second, we didn't have the computational power to do so either. So when you have neither of them, then of course AI had to go into slumber for a while before now we have the opportunity to do so with several things. But we had a lot of folks helping us to build the pathway as of now. So it started with the, Bayes theorem was published 1764. Then Ada Lovelace, the first, they call her the first programmer, the developer of the first algorithm. She was working on the intelligent machine at the time to put this algorithm there. And then George Boole, who was a mathematician who was mostly talking about logic, he talked about the zeros and ones that we see on the matrix and all these things that just yes or no, so we can develop decision support and decision trees. Then Alan Turing said, well, if the AI can fool me to think it's a human, then it passed my test. And indeed, large language models did that. And more recently, we introduced the concept of deep learning, which is emulating the way that we think as in the brain, like multiple neurons in a layer. And then he defeated us in chess and in this game called Go, and then deciphered proteins. And now sky's the limit with ChatGPT and all these different LLMs that are coming up with large language models. So what is that? Because we say AI has been there forever, but it's taken by storm now, and it seems like interesting why this is happening now. Well, it's because now you may have heard about NVIDIA, which is this company that does chips. They used to do video game chips. So as you are looking at the moving around the game, then the computer had to make calculations to see what's coming, like the bad boss is coming, or Mario Kart is you're driving, what's the coming in the street, or this coming a mushroom or whatever. So the same happened on the mathematical equations, but they said let's use the same GPUs of those semiconductors and use them for adjustments for different functions that also use complex mathematical equations. And they created a software called CUDA, and that led to NVIDIA to become the largest company in the world now. There's $4 trillion in market share. That's crazy. because they were able to use the same chips for video games into meaningful things beyond video games, which in this case was calculations for medicine, for space, for quantum computing. Now sky's the limit on that. And we need, thousands of them for in data centers. But that led to generative AI. So what is generative AI? Is basically artificial intelligence that is able to generate content based on algorithms. It could be audio, it could be code, it could be images, it could be text, and is a category of machine learning. And it requires three things. One, a ton of information. It could be any source, but it has to be a ton of them that is meaningful to what we're talking about. Two, it needs this architecture called a transformer, which actually comes from like the Autobots and the Transformers because they were nerds. So same thing. And lastly, prompt engineering, which is the ability for us to ask the right questions to that model. And that is how all these models came to fruition. All follow the same mechanism of adjustments and beyond. And this is the architecture. I'm not going to bore you with that, but it's all focused on the attention. So this is based on a paper called Attention is All You Need. And is basically trying to say how we think about, the next word. So it's always giving you a probability of what is the next token or the next thing that is going to be in that sequence. So if I say, the animal didn't cross the street because it was too tired, you're thinking about the attention was what are we talking about? We're talking about it, which in this case is the animal, right? So the probability of thinking that this is the next token, it was it because it was the animal, is higher than if we say the street. And that's just these algorithms is just that. It's just the mathematical equation to show us what is the next likely item to follow or token in a sequence of thought. And the way they did it, that's why they won the Nobel Prize, is that you put these are the neurons here listed on this thing on the side as the brain. They call it perceptrons, and then they have all these different networks of layers, and the output is here. And based on a system called back propagation, they come back and tell you, that's wrong answer. So you didn't train the system well. Then you give the reward or the punishment, and that adjusts the next time to remember that. The same way we learn, right? So it's like, no, you learn by trial and error. The same happens with this. But as they have tons of information, they need less training because you have tons of information and examples. So that's what is called GPT. It starts generative pre-trained transformer. So now you know what GPT stands for. It comes with the transformer technology, pre-trained in a generative AI approach. So that's what GPT stands for. So, and it's also say, well, now, I don't need a doctor anymore because it's so great and it passed all the tests and USMLEs and the bar exams and the NCLEX, so I don't need nurses anymore. Okay, sure. Of course, if I have an open book and unlimited time, anyone can do this, right? Because it's basically cheating. If the corpus or the information that is in those models is already there and is most likely rewarded as the most likely true, or we call the ground truth, then of course the system, if they have unlimited time, computing time, is going to find the answer right most of the time. The same for us. If you give me an open book exam, and if you give me a year to solve it and it's 100 questions, probably I'm going to get 100%. I mean, I have enough time to do so, unless I'm a doubtful person, but unlikely. So what this is going to help us is mostly to be more efficient, right? Because we have so much time consumed by menial tasks that we physicians don't want to do, but we're forced to because that's the only way we can get paid. So we had to document the thing, send the prior authorization, call the insurance company, talk to the peer-to-peer, all these things that we don't really want to do. We want to focus on the patient, but we had to do it. This is what these technologies are helping us to be better, more efficient, faster, second guess less. So the first step of the things we're doing is using AI. And if people say, oh, using AI, I say, yes, we use it. It's mostly because they're using this called the scribes. So ambient AI is basically a system that is able to listen to us. We had this for years that people record and translate into text. But now that we have the tools to make it more scalable and faster, then they can record information and summarize it and put into a note that it has been trained on tons of examples of prior ways that we document. So same example, you have the GPUs, the computers, right? The LLMs, you have the data that is all this information from prior examples. And then we have the prompt is like, make me a note the same way I write my notes for oncology, right? And with that, you get the answer and you get the documentation. So that's how these ambient scribes are working. There's plenty of them and a lot of people are using them. So if you come and see a doctor, you're going to hear some of that using those technologies. Um, the other things that we're looking into is extraction of information, right? So we have lab results, radiology results, all these things, and we're trying to be more efficient in documenting as well by pulling data. So if I see a new patient, I want to have a summary of what is going on with my patient or what happened recently. So now we can generate that information and it's able to organize it so I can be more efficient to know what happened. So I'm look smarter in front of the patient. And this is what these tools are doing. They're using what we call natural language processing. Some of them do OCR, which is optical character recognition by looking at PDFs and whatever faxes we get, which is to get faxes, believe it or not, in this era of AI. We are faxed out to the limit. We are able to use that information to put the information together and get it into the notes and code and bill. But this has to go beyond that, right? We want to organize laboratory data. We need to organize clinical notes, genomics, monitoring of the patients, and medical images. So we can create what we call a foundational model. And all that is giving us insights into how to be better at diagnosing cancer and diagnosing disease. And to give you an example of how this works is like, well, I don't understand how these machines work. Um, so this is an example of how an X-ray is, for example, classified, and it has to be translated into numbers because all this is mathematical equations. So you put like in this case, you see where the heart is here in this area. You see it's kind of like more dense numbers here. It goes to 255 bits. So from 0 to 255, you have then the clarity or lack thereof. So you can imagine if you see a 161 in the area where it's a 30, there's maybe a long nodule. It shouldn't be there. So maybe the system will flag it, right? And say, what you see in this area more than 50, that should flag you to call out and say, look at this scan better or this image better. So that's how an example of how an X-ray is being seen by computer vision. At the same time, we can do this with other kinds of images. So this is a fundoscopy where we look with the eye on the eye side, in the back of the eye. This is the retina here, and this is the optical disc, the optical nerve disc. And we do just the red, blue, and green, and the same calculations happen. We just combine the colors, and that's how we can do now color vision and understand also changes in textures because of that, the same technologies. So the first step is finding how we can use this for like maybe things like dermatology. What if someone has started with a cetuximab regimen and they have a rash? Is this like Steven Johnson or something to be concerned about? Is it just normal rash comes with EGFR inhibitors? Is it hand-foot syndrome or something else coming from any of the drugs we use, capecitabine or any of the other oral drugs that we have? Or this is something happening because of the checkpoint inhibitor because of MSI high status. Now we can use some of these tools to tell us, and this is an example. So 21 board certified Stanford dermatologists with 1.41 million images look into the algorithm and was able to detect what was benign from malignant and classify it appropriately. And now that's how these algorithms are being used to classify rashes, for example. We can use the same technologies to look for density changes for changes in images by having tons of examples of colonoscopies, videos, and images. We know how a polyp looks under the camera. So now we know it's not only effective to find higher the proportion of colon cancers or colon areas that should be tested, but also it can be cost effective. So in this study, for example, it showed that you can reduce the cost by $57 per test. So it's interesting to see that we can also use it for just putting an algorithm in the camera of the colonoscope to find better polyps. We also can use it for radiology. So this is an example here. Always talk to people and just like, okay, spend 2 seconds, look at these images, look A versus B, and see if you find something. And it's basically showing you that maybe here you can see there's a gorilla here that should not be noted, but actually every single one of those radiologists put their eyes on it. It's called sustained inattentional blindness, and it's a normal phenomenon for humans. I could be focused 100% on you now because I'm at the camera talking to you, and my behind me there could be a fire happening. I couldn't even notice because my attention is all focused on that. That happens with anything we do because we average. We cannot be constantly being distracted by everything, and that happens as well with our attention when we're looking at scans. So what if we can use these technologies to help us to be better? And in some examples, they're not necessarily on colon cancer, but just for mammograms, we know this is real. So areas that are impossible for us to look into the eye with the eyes, they're able to be found by the AI. So these are benign is green, and kind of yellowish red heat map is malignant disease in a inflammatory breast cancer. In a NOAA clinical trial of 80,000 patients, was able to find that using AI integrated mammography reduced the amount of time radiologists had to do reviews by 44%. And he found the same detection rate. So it's basically saving us time so we can get access faster to the test for all the patients involved. And we want to do it for screening of GI malignancies. This is just an example of pancreas cancer that usually has a very hard way to find those lesions in time before surgery can be done. And now using images from before, the patient has diagnosis, they're using these tools to do early cancer detection for pancreas. And we see the same for colon and other cancers as well. And we're talking about the eyes. So we can now do also AI retinal biomarkers. So we can find if the patient has leukemia or myeloma, which is another blood cancer, by just looking at the eyes. And is only unique to them because the proteins that the cancer expresses is able to make changes on those vessels, and that we find that. We can do the same for Scholar Transformer technology for brain tumor segmentation. So if someone has a brain metastasis, we can target it to do better surgeries, to do better radiation. An example here is that a tool that was able to do in 20 minutes what a University of Toronto team will take at least 3 to 5 days to complete. And it can do auto contouring. That means someone is on radiation for rectal cancer and something happened. Now you can be on the table and do auto contouring again and adjust in 3 minutes. So really good to see the developments happening in the radiation side. In terms of other things that are happening in AI is looking at the microbiome. So as you may know, diet is important in colon cancer and other cancers. So in this case, it was able to show us that if, and this is from samples from all over the world, if you do this analysis of DNA genomics of this bacterium, you have these 7 bacterium in the colon, it was able to find that the chances of colon cancer were significantly higher. So what if we add on now with this AI tools able to detect those signals with with technologies we use now for detection? I'm going to write a paper on that soon for review when I'm working with my lab team to publish on how we use colorectal cancer screening using AI and potentially incorporating these insights. We also use this for pathology. As you can imagine, we can look at the scans and like slides and see what are the different areas of importance. And we build this as a foundational model. So this is an example of the National Cancer Institute doing this, creating areas that are like benign, malignant, where the cancer are located and beyond, and just do this tagging because we know pathologies are also scars not only in the United States but beyond. And we need to find insights that can help us to optimize our workflows and find new things. Like for example, in this case, just the orientation of the collagen fibers, which means has nothing to do with the cells, right? We thought just looking at the cells of the cancer or the immune cells. In this case, it's just the collagen around them. Just if they're organized or disorganized tells us if the patient has better response to treatment or not. And in this case, the more disorganized the fibers, the patient had the prolonged survival. So what if we find this across all cancer types and see what it leads us to and what is making those changes? So that's the promise of this. We can also use radiomics, which is a combination of all this data from outcomes and look at images on CAT scans. And as you can tell, this is completely indecipherable to me. It just looks like the same spot, right? But we can see what patients respond to immunotherapy or not, regardless of the biomarker, because of the way the algorithm is able to read this out. And lastly, looking at the vessel straighten up. So we say, oh, how does bevacizumab work? Like we mentioned, like the blood vessel, formation, inhibition, and all that stuff. But we also notice that the way that those vessels are strained and straightened out or kind of convoluted makes a difference. If the cancer cells and the cancer cell has the vessels all messed up, there will be less response to treatment because the immune cells and the cancer treatment kind of gets lost, quote unquote. That's the hypothesis. But if we have a straight line, it's like a pipe. It goes there directly. So we can now predict who may respond better. And that's why bevacizumab is considered one of those things that it may optimize the delivery of the chemo and why we're seeing better outcomes in when we use these drugs for patients. So very interesting to see now the behind the scenes of that. The future is combining all these things together and look at patient data, diagnostic data, train it all in the system, and give you, some insights in who benefits or not of certain interventions. And there's a number of models already happening. So for those who want to learn more, there's tons of things that we can explore. Happy to discuss them in a different, scenario, but just to show you that this is happening in real time. We're doing these tests to help potentially what patients benefit. Of course, we're not close to determine for every single patient in our clinics, but it's only time for us to determine that. So is this AGI or artificial general intelligence? Is this going to replace everyone? I don't believe so. I think that the same way we have tumor boards where we discuss cases individually, we may have multiple agents able to, verify all the information in the best way possible, the way we have surgeons and interventional radiologists and medical oncologists and genetic counselors and biomarker experts and patients and caregivers. All that is part of the treatment plan because physicians are not the only piece of the puzzle. The patient is the key one. And the caregivers, the exposome, the things that are happening in the house, the social determinants of health, all the things are part of the equation and things that AI on its own cannot determine. It has to be a full agent doing all these things, and then an orchestrator putting things together. That's where AGI, if anything, is going to surface. But as of now, artificial general intelligence, which is able to do all these things for everyone, is not even close. And I don't think it will be because our brains are better than any data center that exists. And the amount of connections in a language model is not even close to the brain power as of now. And we have even nuances on top of that because we have neurotransmitters, we have signals, yes and no. We don't even understand ourselves how our brain works. So emulated by doing just perceptrons are not great. It may work for some analytics, but not for everything. But what is this helping us for is for things that are taking a long time for humanity to solve. So one example is protein folding. So in the past, we didn't know how the proteins folded in this realm. So we knew the sequence of the amino acids. We didn't know how the shape of those proteins were. So we can go and attack it with a specific drug. Now we can do it with this AlphaFold, which is we won a Nobel Prize last year as well, because they have all the data. So they just put it in the system, made it run, and then the system was able to deduct based on that how to do that. So it's just a matter of deduction that was able to accomplish that, and it's now an open model that we can leverage. And a lot of people are doing it on the development side. How they're trying to use that, as I mentioned, how these proteins are folding along with medications, and then testing them where they go to fit. and they take pictures on all this. So they call this the large perturbation models, which is basically they perturb the cells, and they take pictures of all of the tiny organelles of the cells, and then see and create these libraries constantly to find better drugs, to the point that sometimes a compound that will take 42 months to find potential candidates, now we can do it in 18 months, and now we're advancing further. And many of them are in clinical trials now. And the idea is to emulate it to the point that we can create a virtual cell. So you may have heard and the Chan Zuckerberg initiative, which is the family from Facebook. They are working on doing these virtual cells. Priscilla Chan and Mark Zuckerberg working on this in the BioHub. So I'm very excited to see what they come about with this to change biology. But now come to the human part in the last few minutes of my presentation. Um, we need to make this interpretable and transparent. So we understand where is this coming from. We need to make sure that the data represents us. So the algorithm gives us information based on us. We need to have ethics to discuss privacy. Of course, we always want to say, oh, my data, my data. But yeah, is my data maybe anonymized, helpful to someone else and make us better? Maybe that's probably a good solution. I mean, people can use my data all they want, as long as they don't take my social security number and my account and use it for nefarious purposes and it's all regulated. I'm all good to share my data so they can find insights of what can help others. But we need to have those frameworks, right? And we have to have a human in the loop always, and not follow just what we call algorithm concordance, which is basically, now these LMs are so confident that then patients just come with me and say, hey, read this out. This is what, whatever LLM is telling you to do. Well, sure. But let's just discuss because maybe the prompt wasn't the specific one. Let's do it together. And I showed you, how we can make this work because I'm an AI user, um, to make me better, not to replace me, not to think that the AI knows more than me, maybe knows more about certain topics or does the information retrieval faster, but doesn't know my patient. And that's as important as the technical knowledge. So, what can we do for in the AI space for oncology? And what are the things? So we're stuck because we're dealing with all this craziness, right? Prioritization, we have EMRs, we have images coming along, we have automation fatigue, we have 15 minutes to spend per patient because that's how the systems are built. And also we're missing biomarkers because of that, so we cannot really tag patients in real time. And that led to the clinical trial enrollment paradox, which led me to be focused on this on my daily living. Because out of the 12 million cancer patients diagnosed in the last decade, only 0.1% enroll in clinical trials, which makes no sense. And half of the studies are closing because there's not enough patients. And there's 14,100 active clinical trials at any given time. So there is globally 18 million new patients alone, just new, without counting those who are still on treatment, being diagnosed with cancer every year, with 2 million of them in the US alone. How is that possible? Those trials are not to the rim. They should be completely full, and we're just asking for more slots, but they're just not. And that means because the solution is because there is no connectivity between sites and patients and having that information together, because patients want to participate in trials and sites want to enroll them, but they don't have a way to know, you don't know the love of your life, even if it's around you, because no one has introduced you to them, right? So that's how you have to, use a solution, an engine that is patient-centric and is helpful to do so. So that's something that we know is important. We need to solve because the patients are not static. There is dynamic, and there's this constant data drift because, treatment changes, the trial changes, the new treatments are coming up. We have disease progression. We have new biomarkers in our cancers. We change performance status. And all these are making it, a way that we need to think about it more as a digital solution, like logistic for clinical trials, like Instacart or Uber or Amazon. We should be able to use the same data information in a meaningful way to help us in a dynamic way. Because even if we screen everyone today, it will not be helpful because very few will be eligible at this moment. They will be eligible in a month, in several months, and we need to calculate that. And the regulation is changing now because now we can potentially use things at the point of care. There is 85% of the patients live in places that are not really focused on clinical trials. They're focused on delivery care in a good quality. But how can we do this to bring trials at scale? So one way is to use AI. In this analysis that we published in ASCO, we're able to decrease by 99.9% the amount of time involved. So 5,000 patients with all kinds of cancers, including colon, were able to be pre-screened for trials. And it took 1 hour, what it would have taken 19,500 hours. And also found who was missing biomarkers, and it doubled the amount of trial options for those patients in real time. So this is something that it can be completely doable. We just have to put patients on pre-screening hubs. Basically, they enter these hubs and we monitor them over time. So when the time is right, voila, you have the treatment option available and you're free to choose your standard of care with your doctor, or you can look for clinical trials, or we can bring the trial to you. But we need to know that that possibility exists for everyone to be part of that. So I call that the click and mortar approach using AI. And to prove that AI-powered pre-screening hub, we did a pilot with the American Cancer Society for 8 months. That was extremely successful. And so now I'm happy to announce that the American Society has now opened the ACS Act to all the countries. So this is completely open to any cancer patient in the United States. So please, please, please spread the word, not only with colon cancer patients, with everyone who you know in the infusion chair, anywhere. Just let them know that there's opportunity for not only find a clinical trial, option that can guide you and get you there, but also you have all the support of ACS. You have education, you have assessment of needs, you have navigation, you can get hope lodge assessment, transportation, lodging, support for families. And this is all under the auspice of ACS, which is, something that we're so happy to be working with them, because now we can offer this to any patient. So please, please spread the word. This is the QR code. This is free, completely free to any patient in the United States. So please take advantage of this, because it's an amazing opportunity to get trial options, not only now, but also in the future, because you can continue to be monitored. And this is going to change the paradigm, because we're going to be only not helping for clinical trials, but also to optimize testing, to appropriately set up the clinical trial optimization so patients can be treated at the point of care. And we can do it safely and decentralized by using what's called federated learning, which is the ability to deploy that algorithm into multiple enterprises. And I think there's a question now, so I'll be happy to take it.
Hi, this is Andy. I put the question in the Q&A, but it's closed. But I was just going to say I'm super interested in these trials, and I just read about the American Cancer Society last night on a website, on a patient board. But I'm going back to a slide you had way back when about ctDNA and dynamic changes.
Okay, yes.
And that was just fascinating. I'm sure patients are super interested in how you can use CTC during treatment. I know a lot of it's reading yet, but that was an exciting slide.
And yeah, absolutely. And it's just one of those emerging technologies that now we can really leverage our ability to test in real time and the signals are getting better now, because for example, there was just a paper a couple of days ago. ctDNA usually excludes platelets from the testing because they didn't see as it was meaningful to test the platelets for the DNA. But now there's evidence that there's micro vesicles attached to the platelets, and he had a ton of DNA from the tumor collected there. So now if we incorporate ctDNA and we collect the platelet DNA that is attached with those microvesicles, we may be able to find biomarkers that were lost in the testing before. So once again, the sky's the limit now in how we're doing these assessments. We're looking for RNA in the blood. Is just completely crazy that we're living this era that we just simply send a blood test and we're able to find insights sometimes in a week or so. I have a very close example of a patient of mine who she's in late 80s. She's been following me for about 5.5 years, and she was seeing me for just second opinion. And I sent a liquid biopsy, planned for her to just get, capecitabine and bevacizumab as treatment because, she was in a wheelchair and she was like, okay, not feeling well. Uh, and it found MSI high, even though she didn't have any history and the tumor didn't have it. It was just found the ctDNA. And it's actually real. I gave the patient pembrolizumab, and she had a complete response. So I was able to actually stop her. Just like, don't take this. We're gonna give you this because at the time the keynote 177 had come up, and I was able to give her pembrolizumab. And I'm so happy because now, because of these things, we're able to get patients better treatments. So now incorporating AI on all that is going to be even more consequential. So those are like one example of the day that makes us, motivated into, keep fighting this cancer, find these cures. So thank you for that. Um,
And also just say that there's all this stuff about trial matching, like the whole, instead of looking over, think about Uber and what that offers. It's so timely and just, one of the people online is Dylan Eisenhower, Canada. He just opened a website for trial matching that includes AI. And as you said, the amount of time in 10 minutes, you can find some AI matches for your profile. And, if, but there's some of the things that you brought up that ACS is doing is like in the future for development. There's so many things like a new trial location, and that's incredibly into patients. And, that you can just put your stuff in there, and then as things change, you can look for more trials of what's open since the last time I looked. It's sort of like a savings account for trial options. So anyway,
Absolutely.
I'm super excited about re-looking at all those slides because I've been helping them beta test, and it's been incredible. And a lot of people in other countries, going back to the ACS and second look cancer, like they don't have options to like trial matching services that we do in the US. So to have people in the UK have options is a big deal. So thank you. Thank you.
No, of course. Yeah. And Masabali is global. So yeah, if there's anyone outside the country watching this as well, happy to, give you a free clinical trial matching report. Um, just ACS is just comprehensive because it's basically a full concierge end to end, which is like a dream, right? So that's amazing. And I'm glad that they're doing it and so happy that it's going to, be so good for so many folks. The next question is that, okay, are you my new doctor? That's what people think about AI, or at least they promote. And even a study today came from the New England Journal of Medicine AI, where it showed that if for oncology use case, it was, better than trainees, but it was never better than oncologists, even with the RAG and all these things that they do, these techniques to distill information. So yeah, don't replace us just yet. We still take the pager, we still do the prioritization, we still call you, we still care about you. Um, and of course we can use AI to amplify us and to be better. But yeah, we're still major part of the equation because all humans, we want to be better. We want to cure cancers. I mean, there's plenty of cancer patients around, unfortunately. We're here to help as many as we can. We're fortunate in the United States that even though we have a shortage of oncologists and all kinds of physicians, we have still the more per capita in the world. From Colombia, there's less than 500 oncologists for like 45 million people. So you can imagine how difficult it can be to get treatment. So I think we're very privileged here, and we should cherish and be happy about that and take advantage of that and help others, of course, with that. So the way I look into this is, keeping it human. So AI's augmentation is not replacement. I put some insights on this New England Journal of Medicine AI paper early in the year with Scott Pemberty, who's also dedicated in cancer because of his brother is an oncologist, but he's a technologist and he's at the Google office, one of those major roles. But we just come together and talk about this. AI, it's as you maybe believe evolution or intelligent design, whichever, that process, that architect, that design, even nature, beyond how whatever you wish to believe, it spends so much time, so many years, millions of years to make us ability to have, these neural cognitive assessments that we're able to look someone in the eyes in a second and know something's wrong. AI cannot do that. The AI doesn't have the dexterity to touch you, to hold you, to even do any major surgery as of now. I mean, of course, they can maybe do it in a few years, robotics wise, but even the most enthusiasts will not get neurosurgery or get their children treated by a robot yet. So that tells you a lot. What's easy for AI is things that are very recent. So mathematical equations, they're recent, right? There's less than 5,000 years. Language is very recent. We didn't speak English even less than that, right? So language and mathematics and all that, they're very recent. So AI can be very efficient into doing so. In this case, rapid trial eligibility or EHR automation, doing an automatic note of your case, or do analysis at large scale that will take many years. But things are empathy and physical dexterity and contextual flexibility, understanding what's happening in front of us and read the room. AI doesn't have that and will not have it for a long, long time. Even if we have quantum computing capabilities, which I'm very interested in working on some of those things, but still, so human element is always key.
And it looks like we have a question, if we could just jump in very quickly from Julie.
I don't hear Julie. Yeah, she's you're muted, Julie.
Yeah, yeah, sorry. All of my buttons are not working. I have a question. This is really just amazing how many different modalities and tools and ways AI can influence and help in what we're doing or what doctors are trying to do for us. But I have a question about some of the just commercialization, I guess, and kind of where are some of these on the curve of use and pervasiveness in the clinic or like the radiology ones, like in the use of patient care?
Yeah, so the ones that have been deployed are so the ones deployed right now are ambient AI, that's the most commonly one. EHR summarization, which is basically the same data, just verification with source. Those are the ones that are really there. The radiologies and digital pathology ones that are just emerging. So for radiology, we're mostly using them for screening, for triaging, for example, in the case of like a fracture, because it's very objective, right? There's no probability. It's more like, okay, you have a fracture or not, right? Because you know how the bone looks when it's healthy. Unless there's like fringes cases, that's when the AI is not as good because it doesn't have enough examples. So it's not good for rare disease because it doesn't have enough samples. It may be helpful in the future to do for clinical trials, maybe to do synthetic arms with the data. And so we don't have to put patients on placebos or something like that, or simulate them for causal machine learning, we call that. But as of now, they're mostly, even the mammogram that we're talking about, they're still very early. And even in the United States, to validate it, we are leveraging like clinical trials. So it just opened up, probably I think this month, a clinical trial for mammography aid by AI, so it can be contextualized to the United States because the breast density of female patients in the United States is different from Europe, for example, and that makes a difference in how the algorithms are built and deployed and explainable and generalizable. So there was a paper just published also just I think the last week that show that out of the more than 1,000 FDA, bypass, I mean, in terms of like there's an approval, but it's an approval that is not really for clinical trial based. It's just based on accuracy and analytical data. That only very few of them have been taken into clinical trials. So I think that the winners are going to be those who go for trials and actually going to be adopted. I don't think any of us in the clinic and myself, I have a leadership role in my organization. We don't deploy AI algorithms as they come. We vet them very judiciously and only use them when they're going to be helpful for us to be better in decision making. And to the point that things like, people use like, there's, LLMs that they use for data gathering. We don't really use them internally because we don't know the accuracy of some of them. And we don't want also de-skilling, which means that people will become reliable on these algorithms. So they may use some software. I mean, you have heard I see on Twitter that, oh yeah, all my doctors use open evidence and they do that all the time. Yeah, that's great. for prior authorization, I can copy paste, or if I want to teach you something about a drug that is new and I want to have the information pull out, it's copy pasted, put it there, and it's going to be accurate. That's great. But when he's talking about, or maybe the dose of a drug that I missed, but I don't use it all the time. I use it only for the few things that I don't remember because, we are masters of our own trade after a while. So unless you are sclerotic and don't remember things for many years because you haven't taken your boards, which would be weird, and not because you're getting CMEs and trained and we have requirements for licensure, particularly in the oncology space, I doubt there's going to be a major need for those tools, at least for data queries. So it's still just all this talk about is basically that there's still a lot of opportunity for adoption. And this is just a visionary example of the things that we're looking for to optimize and why it's so important to have clinical trials, because that's the way to validate these tools in the context of the United States and beyond. And we can generalize it in the best way possible. So that's where we are now. And okay, now move forward on this. So in a few more minutes, I know we have on the webinar. Is it Michelle? Yeah.
Yeah, I had a kind of a follow-up question to that. So it feels like there's sort of this division in the field of AI, where there's sort of the professional side, which are these systems that are being implemented in the medical community kind of behind the scenes. But then there's the large language models that we as patients are seeing and using, potentially day to day. And those sort of feel like those two things are almost diverging. And where you have sort of more control in the clinical setting or in the models that are being trained and used in a scientific manner versus the ones that are being used day to day by the average consumer. How do we protect ourselves as patients and caregivers from getting, bad information from the side of things that we have access to? And how do we, interact with you guys as physicians over the type of information that we're getting, from those large language models?
Yeah, I know. I agree. That's super important. I love informed patients, but also I don't want that they be misinformed because of things that misinformation means that they have the right intentions, but they're looking at the wrong sources, right? So they're misinformed. That's different from disinformation. That means that someone is, purposely deceiving. I think all my patients are, if they have any misconception, is because of a bad data source. So we just, like, for example, there was this paper in Medscape, that the opinion piece that was published by a reporter, and I was quoted on that there's certain people who are doing dogmas about certain drugs, like, ivermectin and mebendazole and febendazole, and every patient is asking me about them, and I'm thinking in the same way. Um, the if those drugs work, I mean, they're probably available. There's right to try legislation. People can try them, but they don't work because they don't have anti-cancer properties at the right concentrations. So, but they still want to try it, and they think we're hiding them from them because we're going to make profit out of that. It was like, well, you have to look at the price of 5-FU and realize that there's not really a thing. Or capsaicin pills, you can get them for like cost plus drugs from Marcuban and $100 a month, probably way cheaper than the prescriptions of ivermectin or mebendazole or whatever you can get from online, X or Twitter, thinking that there's the cure. So I'm doing the same way. Instead of seeing it as a negative thing, I see it as an open opportunity, because I know they want to seek information because they want to empower themselves. We want control, and seeking information, looking for cures is the most human thing we can do. It's just whatever we want to do. There's always people volunteering information because they want to help. So what I approach this way is like, okay, show me what you have and let me discuss it. And let's do the prompts together and show you based on algorithms that we know and things that are proven, like the data sources. Let's vet those data sources, because that's the thing behind the scenes. The black box situation is what should be avoided. So black box is basically not knowing what was how was the output coming around. We need to have in medicine, there should not be black boxes, in particularly with data from information found on the internet, right? It should be fully clear where it came from what tests, or how many patients were tested, all that rigor, because that is the things that we can usually explain and what patients have access to. Patients don't have access to, like, large foundational models of multimodal images and genomics and understand the whole thing. Because even ourselves don't have all that ability in all sources. So what they have is, Dr. ChatGPT, Dr. Google, Dr. Whichever LLM they use, Perplexity or Grok, or Claude, any of those are there. And the idea is that, okay, show me what questions do you make, because maybe you don't have bone cancer, you have colon cancer metastatic to the bone, and you are looking at this drug thinking that may help you, or looking for immunotherapy. When we look at your biomarkers, look at your genomics, I don't think you may know that you may not have these molecular alterations that lead you to respond to immunotherapy. But you may be eligible for a trial. So let's try this so you can be eligible for a trial in the future. So that's the way I approach this. And so open communication is the key. And having that level of literacy is important. So that's what I try to empower patients to do with me.
And we have a comment from Annie who says that it's a great point about using Google or ChatGPT. And a lot of patients are getting freaked out by having different mutations, for example, the KRAS G12V or KRAS A146T.
Yeah, and that's the part of that. Now they're looking at genomics and trying to translate it. So what I then is when we come to the conversation and listen, well, KRAS mutations are extremely common in colon cancer. Half of them have them to some extent in some variant. And I had to explain the differences between the G12D versus G12V, because G12C and G13D, and that there are drugs for G12C right now, and there are also drugs for the other ones, but under clinical trials. So we're looking for certain things. We have to look for protein degraders or KRAS degrader studies, or vaccines, Dr. Rosenberg at NIH, NCI, and beyond. So that's why it's so important to have also this knowledge in real time of dynamic changes that happen, because sometimes even those mutations are emergent. You may have biomarker testing today done with liquid biopsies or tissue-based, and then a few months later, then you have a new alteration. It could be a HER2 positivity that now you can target with any of those drugs that like immunoconjugates, right? So it's a matter of having the information at the right time with the right context. So the data and context are the most important components, and just have that communication open with us so we can explain you further. But once again, yes, everyone needs to be tested and biomarker tested, and you need to know your clinical trial options all the time. That's my motto, right? That's how you can move things forward. All right. So just to give you a little bit more on this, couple final slides, there's only two more left. If you want to learn more about how we are looking as physicians into AI in the future, I had the privilege to write the paper as first author for the ASCO educational book on AI. It's actually the number one downloaded chapter from the book based on age, and we're very happy to see the reception. It's free to download, free to share, free to tell to people, the same as all these other things we're talking about. There's something published by the NIH there. You want to learn more about that too. And the idea is to have this planetary AI with trial hubs, with the patients are always first in the network. This is not futuristic. We can really activate all these different deployments, at least for the data side and the clinical trial side, if we do it at scale with everyone being part of the equation. So we're moving decades of manual inefficiency to real-time AI-enabled patient-centric trial matching and beyond. So I will be happy to see everyone looking at those options and leveraging, ACSX and all the things we're doing. This is not futuristic. This is something that is actionable now. And with that, I always finish with this presentation of with it, Théâtre d'Opéra Spécial, which is French for Space Opera Theater. This is an image was created by generative AI using, a prompt, and it just became news because it won an award. But to me, it's one of those pictures that shows me the beauty between human and technology. And it's also a kind of open window of a new future, new things that are going to give us better chances to improve, cancer patients' journeys, and not only that, but us as humanity. So, we have to embrace it with safety, human in the loop always. and collaborative approach. And I'm hopeful that this lecture today was helpful to give you some insights of what's happening in the space. This presentation has changed over several times over many months that I've been doing this lecture. So I'm always excited because it's always changing. So I'm changing as the AI is changing. So it's always good to have this opportunity to discuss. Let me check. You have a question, I think. Let me raise your hand.
Yes. Yeah, I just had one more question, and this is sort of a practical thing. I know you're a big user of artificial intelligence yourself, and when you're going in to ask a question, do you have certain prompt tips or things that you sort of do to make sure that you're getting accurate information, and how do you verify the information that you're getting?
Yeah, so it depends on what you're using. So of course, I use ChatGPT. I use Gemini as well to verify with one another. And I also use Perplexity. So Perplexity has the ability to change models, so you can just choose what model you like the best based on the responses. So that's one first thing I do to let you know. I use Grok, but more for like data sourcing and stuff, not for medical questions, because it doesn't really have any major context as of yet. It has a lot of capacity, but not depth in that sense. The ones who think more is the ones that I like the best. So always, if you're asking a question about yourself, always put it in the deep research mode. I know they're not free all the time, but there's always a few instances per week that you can use it for free. So use the deep research first and make sure that the prompt, it can be as long as you want it to be, because it has to be about you and the question you're asking. You don't have to be succinct. It does have it, the AI has all the time in the world, so you can spend as much time just typing it down and making the whole questions at the end. Be very focused, give context. So the first thing is giving context. So it's like, I'm a 65-year-old male living in California who has, a stage 4 colon cancer diagnosed in 2012. And I've been, 13 years in the making with multiple lines of therapy. And my lines have been as follows: this. My last test was this, and my last treatment was that. I would like to know what would be the potential treatment options ahead for me beyond clinical trials, because clinical trials you have help. If you don't use ChatGPT for clinical trial options, because it will not help you, it will be very broad and not specific. It will not pull from the right sources. It will be just publicly available and will be completely disorganized and missing a lot of pieces. But you say, looking for this, or explain me this biomarker, and then you just simply ask the question and let it flow. If you do deep research, it's going to be always helpful to give you the right information. And you can tell them, explain to me as someone who doesn't have any background knowledge in medicine. I'm a patient. Just give me as information as if you were an expert. And you have to give the context. You said, you are an expert in cancer genomics results. These are the following results I want you to review. And that way you don't put it personalized, so the system doesn't flag you as giving you medical information advice. So you put it always kind of like, you can put it also in third person, so it doesn't link you directly. So the system doesn't flag you as I won't do it for you because I don't want to give you, medical advice. And lastly, you can say, look all verifiable data sources, including PubMed, Google Scholars, and ASCO latest, results, ASCO GI latest updates. And that way it's going to go into, instead of looking broadly, it's going to go to the area of the library that is relevant to the point that you're seeking. That's how the systems are going to be better leveraged for what you're looking for. In that way, you can solve things easier and have some information that you really need.
That's great. Thank you very much. That helps me personally a lot as well. We do have another question that came in through the chat, and the question is, what is an actionable way to use the ACS ACTS trial matches? Should we bring those results back to our oncology team?
So yes, so there's two ways when you have this access. So as you own your journey, right? So I always tell my patients, so if you have a clinical trial that they're eligible for, like, we have a sense of ownership to our patients, and there's a sense of extreme loyalty from our patients, which I appreciate. But I also think that, not every single system is perfect. Not every single center has all the trials, and not every single, even the most advanced centers, have the interest of getting every patient into a trial, because even those centers that have the most amount of prestige based on trial enrollment, they enroll up to like 15-12%. So out of their 100% of patients, only 15% get into trials, and that's their mission. That's where they get millions of dollars by NIH, right? So that tells you a lot that there's a lot of variability in how those trials are offered. So the ACS Act is a good opportunity to also give that information to a very busy clinician that may not even remember that the trial is even open at their own institution. Don't be surprised if that happens. Because people are busy. They don't know if, when things are kind of disorganized, the phase 1 unit is different from the unit of GI, and they may have a trial that actually is perfect for you, but because they're not meeting in the same place, they don't have the chance to talk to one another. And if the one trial enrolling well, you get offered that study. Just one example. Or the PI has that specific study and they want to put you on that trial because that's their study, and they could be a better study across. So it's better to have all the options in front of you. And at the end of the day, this is your life. This is you as a patient. And this is what I would like for every single patient of mine, or my family, of myself. I want to have empowerment of information, and then I can make the best decisions possible. So yes, bring it to your oncologist. And also, if you want to seek, instead of doing random second opinions around across the country, use the clinical trial as an avenue to tailor yourself to the right places based on location, so you can go to the right place for the right trials. And if you want to travel, 500 miles away for a trial because it's the ideal one for you, that's your choice as well. But use that information to be really relevant to your case, to your insurance, to your things that you're seeking for, and what you want to be. So see it a plethora of opportunities that you didn't have before. And the best thing about it is that the American Society, which is in every single institution in the United States, even the tiniest community center, has an ACS liaison. Now you can connect the dots and get to the right place using their tools and support and funding for lodging, for anything you need. So it's really something that is completely remarkable, and something that hopefully the whole world emulates, because this is something that is, to me, amazing.
Okay, so we have a comment here also. Fantastic advice regarding tailoring the questions, especially recent trial readouts, and using trial matching for second opinion strategies. I think, what this whole talk has sort of taught me is that it's not AI is going to have opportunities for us as patients to do things very differently. And, that it may become more of a partner for us and our physicians to kind of move the balls forward as all of these things come together. Do you have any last pieces of advice for us that you've got?
No, yeah, to me, it's all about, keep empowered, keep asking the right questions, and be open with your doctors about the searches that you're doing. We want to, give you the right advice. At least most of us, of course, there's variability in humanity, the same as variability in patients and in the AIs themselves. But I think all of us, in a mission to, to live longer, better lives, and to really eradicate this, stupid cancer I hate so much. So, be in the loop. If you want to learn more about what I do about those topics, I have a column in Medscape. So you want to read it out. There's no incentive to me except for people getting education. So if you have a question that you want to solve about practical AI, please send it my way. I'll be happy to put it in the column or collect them so I can, put it into future ideas for people to read.
Well, we cannot thank you enough. This is a hot topic for all of us, I think, both as patients, caregivers, and just practically in the, human beings in the world right now. And you clearly have a lot of expertise in this area, and we certainly appreciate your time. So
Well, thank you for having me.
with that, we will, I think, conclude our webinar today.
All right. Have a great, wonderful rest of the day, week, and holidays and life. Please enjoy it every day.
Thank you.